The Millau Bridge. Its full name is Le Viaduc de Millau, and it is located in France, between the communes of Millau and Grisons, in the department of Aveyron. The bridge was built in order to help to cross the valley of the Tarn River. Its design is deeply related to the search for an aesthetically structure, led to the choice of a multi-cable stayed viaduct with a slender piers and a very light deck, touching the valley at only 7 points. The two persons involved in its design were Michael Berlioz, who's a French engineer, and Norman Foster, a recognized British architect. It is a cable-stayed bridge, which means that it is a bridge whose deck is supported at several points by stays and rests on one or more towers, and its deck and pylons are entirely of metal, exactly steels of grade S355 and S460. The Millau Bridge has a total length of 2,460 meters, width of 32 meters, and its longest span is 342 meters. In the technological aspects, we get to say that the electrical installations of the viaduct are impressive. There are 30 kilometers of high current cables, 20 kilometers of fiber optics, 10 kilometers of low current cables, which are situated on deck, on the pylons and on the masts. In the instrumentation field, the viaduct is a state of the art. The pylons, deck, masts, and stays are equipped of sensors. These are designed to detect the slightest movement in the viaduct and measure its resistance. 12 fiber optics extensometers were installed in the base of pylon P2. These sensors detect movements on the order of a micrometer. Other extensometers, electrical this time, are distributed on top of P2 and P7. This apparatus is capable of taking up to 100 readings per second. In high winds, they continuously monitor the reaction of the viaduct to extreme conditions. Additionally, two piezoelectric sensors gather traffic data: weight of the vehicles, average speed, density of the flow of traffic, etc. This system can distinguish between 14 different types of vehicles. Advantages. First, the Millau Viaduct is equipped with safety barriers built to withstand truck impacts. Second, the viaduct's trajectory respects the area's major natural sites and the exceptional landscape of the confluence of the Torby and Tarn valleys. Third, the factory pre-production of certain parts of the deck reduced the volume of material that had to be worked on site. Fourth, thanks to the viaduct effect, the mayor of millau approved more than 100 building permits in 18 months for the construction of 3 hotels, plus other business and industries. Millau has seen an economic boom since the bridge opened. Fifth, the 2 industrial zones in La Cavalerie in the south and Séverac-le-Château to the north have both expanded greatly, accommodating new enterprises, both local and national. Sixth, is an excellent example of a sustainable solution for a transport problem in a situation where economic and ecological interests appear to be virtually irreconcilable. Disadvantages. The millau viaduct really doesn't present major disadvantages, but before its construction, numerous organizations opposed the project, including the WWF, France Nature Environment, the National Federation of Motor Users, and the Environmental Action, and they put forward several arguments. First, the westernmost route would be better, longer by 3 kilometers, but a third of the coast with its 3 more conventional structures. Second, the project will never break even. Toll income will never amortize the initial investments, and the contractor will have to be supported by subsidies. Third, the technical difficulties were too great, and the bridge will be dangerous and unsustainable. The pylons sitting on the shale of the Tarn Valley will not support the structure adequately. Fourth, the viaduct represents a detour, reducing the number of visitors passing through millau and slowing its economy.